So today we're going to be talking about the rate of change. So we just did an activity that dealt with rate of change. Here is the formal definition of what rate of change is. It's a ratio that describes how much one quantity changes with respect to another quantity. How much one quantity changes with respect to another quantity. And so the definition of rate of change when we deal with math is the change in y over the change in x. Now when you did your activity, I had something different. What did I have instead of change in y over change in x? Yeah. What was it? Rise over run. Now these are synonymous with change in y and change in x. So when you hear rise, that means change in y. When you hear run, that means change in x. And that should make sense because when you think about a coordinate plane, your x's and your y's, when you think about up and down, that's the y-axis. When you think about the run, left to right, like what you did on your activity, that is the change in x. And so rate of change, rise divided by run. And so now what we're going to do is we're going to look at an example here. And it says, use the table to find the rate of change. Explain its meaning. Now this is used a lot. If you look at this table, it talks about number of computer games and the total cost. So we need to find the rate of change. So what we're going to do is we're going to pick two XY pairs. So what I'm going to choose to do is I'm going to just choose to take the very first two pairs. So I'm going to take this pair right here. And I'm going to take this pair right here. Now, if you remember the definition of rate of change, it was change in y divided by change in x. Okay, so rate of change, R-O-C. Okay, change in y. So what did I do from the blue to the pink? I went from 78 to 156. So I'm going to go ahead and subtract those two. So do you see what I did? I'm going to take this minus this. Now what I'm going to do is the exact same thing. So if I start with the blue, I've got to continue to start with the blue here. So I'm going to divide that by 4 minus 2. So what is 156 minus 78?
78.
It's 78 divided by 2. So my rate of change is 39. So now what they want you to do is they want you to put that into context a little bit. Well, let's think about 156 and 78 were dollars, total cost, right? The total number of games was X. What do you think this 39 represents? So think about it real quick. I'm going to give you about 10 seconds. What do you think this 39 represents? So I've got about 5 more. What does the 39 represent then? Yeah, go ahead.
1x, like the 1x equals
Okay, so just in words, what does it mean? We got
$39 per video game.
$39 per video game, per computer game. So each computer game costs $39. That's what that represents. Okay? All right, with your expressions, here you go. I want you to figure out, if you notice it says the table shows how the tiled surface area changes with the number of floor tiles. Find the rate of change. So find the rate of change. When you find the rate of change, I need you to enter that into your expressions. So find the rate of change.
that big.
No.
Oh, really?
16, no, not really.
The ones like in the lab
It's
are only,
inches,
are
though.
12 inch.
It's inches. I've
Like the
seen
ones,
bigger.
the ones in the commons and stuff are 12 inch tiles. Yeah, it's not that big.
They make pretty big tiles.
At malls, they have
The
tiles that are like the
backwash
size
on
of
my,
my
the
bedroom.
backwash on my aunt's kitchen, they have really big.
It's not the
All
back
right, so
wall,
let's
it's the back
see
wall.
what you all got.
She
Great,
knows
nice
so
job.
much.
Everybody got 16. So now let's put into context, what does that 16 mean? Got it?
Yes.
Yeah, okay.
Let me say it. A tile covers 16 square inches.
Right. Okay, if you didn't catch that, one tile covers 16 square inches. Now that might not seem like a big deal. It actually is. If you're going to tile any floors in your houses in the future, that's what you do. You find the area of your entire floor, you go to a store and they say, okay, these tiles cover this many square inches. And so then you figure out how many tiles you're going to need. All right, let's go ahead and look at this real quick. Oh, we got something here in blue, which means it must be something pretty important. For a function to be linear, what does linear mean again? Line. So a line means everything we looked at yesterday with GeoGebra, all of those lines. For a function to be linear, the rate of change must stay constant. Or it must stay, what's another word for constant? Unchanges, it must stay the same. Okay? So for a function to be linear, the rate of change must stay the same. Okay? So this is what we're going to do. We've got a bunch of rate of changes that we need to find. So the easiest way to do this is to start with the first two. Okay? So I'm going to start with the first two. What do I do from here to here? Okay? I would subtract 15 minus 11, and what do you get? 4. What do you get when you do this here? What do you do when you subtract negative 2 minus negative 3? Positive 1. For those of you that are wondering, let's do this. Negative 2 minus negative 3. Your two negatives here make a positive, and you get 1. Okay, so now we did that, and so the rate of change there would be 4 over 1. Okay, so the rate of change is 4 over 1, which is 4. Now what we're going to do is we're going to do the same thing with the next two. What do you do from here to here? Subtract, and what do you get? 4. Here to here, what do? You subtract, and you get 1. So here I get 4 divided by 1, so my rate of change is 4. Let's look at the next one. What do you do from here to here? Subtract, and what do you get? 4. What do you get when you subtract those? 1 minus negative 1. 2. So my rate of change there would be 4 over 2, which is 2. So is this function linear? No, it's not, because this 2 screwed everything up. You have to check every one. I'm going to give you a little hint about me. I'm one of those that's going to make sure you check every one, and so come test time, I'm probably going to give you one that doesn't work at the very end. So don't just do the first 2 or 3 and say, oh, they all work, so I'm going to do that, because I'm not going to probably do something like that.
Can we start from the end?
Might be a thought too. So determine whether each function is linear. This is not linear. So now this is what you need to do. Determine whether this function is linear. Yes or no. Go through the exact same steps that we did. So you're first of all going to start with this to this. And I'll get you even started. What's that difference there? 5. What's this difference here going to be? Negative 3. So your rate of change on that one would be negative 5 thirds. Yes, it can be a negative. So I will let you finish and pick the other rate of changes and see. When you get your answer, you need to go ahead and text it in. No, it's 9 minus 12. Remember, we do 1 minus negative 4 over 9 minus 12.
I
Okay?
thought you stopped from the top.
No, because if I start over from the top on y, negative 4 minus 1 would be negative 5.
Okay. And the next one we do 16.
You'll see why I'm always doing that way first, when we start getting into more stuff in this section.
Well, not good for you.
And the answer is yes, nice job. Now, some of you are probably figuring out what you're doing. One, first of all, you said I asked a no question earlier, so this one's gotta be yes, okay? The other thing you're probably figuring out is that you're looking for patterns in the table. And that's fine, you can do that. You could say, oh, well, I noticed the difference here is 5, the difference here is 5, the distance here is 5. Great. Difference here is negative 3, negative 3, negative 3. So since all those differences are the same, it's going to be linear. So that's another way you could do that. Okay, so real quick again, rate of change is what?
Change in y divided by
Change in y divided by change in x. What's another way to say rate of change? Rise over run. Okay, now eventually we're going to start talking about slope, but we're going to leave that for Monday. So now what I need you to do on pages 177 through 178, so I want you to turn in your book right now so that we know what's expected of us. On pages 177 through 178, it's 14 through 23. Okay, 14 through 23. So if you look at the first two, they say find the rate of change using the table, which we did. If you look at 16 and 17, okay, I need you to look at 16 and 17 so you understand here. 16 and 17 say find the rate of change represented in each graph. So if you look at 16, it gives you 2 points. Those are the 2 points you're going to focus on. So on 16, the points are negative 3, 7, and 3, negative 1. So the rise is change in y. So I'm going to start at the leftmost point. Okay, what is my rise from the leftmost point to the rightmost point? What is the change in y? What is the change in y? It has went down how far? 8. So how do you symbolize down 8? Negative 8. So its change in y is negative 8. Now its run is the change in x. So how far has it changed in x? How far? 6. Good. So your rate of change is negative 8/6. Now real quick, okay? Real quick, that can be reduced. You should all recognize those are both even numbers, which means they're both divisible by 2. Yes, and exactly right. That's exactly right. So your answer here would be negative 4 over 3. So now 17 is going to be the same way. Start at your leftmost point, go to your rightmost point.
And you have to divide it.
Wait, that
And
was
then
16?
you have to divide. That was 16. So on 17, do it the same way. And then, so your assignment is 14 through 23. If you have questions, come in Monday morning or even sometime today. So that is due Monday, start a class.